Hello everyone, welcome to Jnana Samruddhi Institute. In this video, we'll learn the engineering mathematics topic Fourier series. Most engineering students fail Fourier series concepts because they make tiny integration mistakes and lose marks instantly. Your integration basics are weak, don't panic. In this video, I will show you a simple steps to solve any easily. Now let's begin with the problem. Obtain the Fourier series of f of x equals pi minus x by 2 in the range 0 to 2 pi, and hence deduce that to 4 equals 1 minus 1 by 3 plus 1 by 7 and so on. So now let's begin. How to solve this problem? Solution. First we'll write the given thing. In this question they have given f of x. F of x equals pi minus x by 2. Pi minus x by 2 in the range 0 to 2 pi. The first step is we need to check whether the given function is even or odd. So in order to check the function is even or odd for the range 0 to 2 pi, first we need to check in the place of x we need to replace 2 pi minus x. If we replace 2 pi minus x, if we get f of x, then such function will consider it as even. If the function is even, then the value a0 and an will exist. The value for bn will become 0. If the function is even function, the bn value will become 0. So if we substitute in the place of x, substitute 2 pi minus x, if we get minus f of x, then the function will be odd. If the function is odd function, a0 and an 0, both will become 0. So now first let's check. The place of x will replace 2 pi minus x. Pi minus in the place of x will replace with 2 pi minus x. That is pi minus 2 pi plus x divided by 2. So f of pi minus is minus pi plus x. If we take minus common, then pi minus x divided by. This is almost equal to minus. So for the f of 2 pi minus x, we got minus f of x. So hence the function is odd function. Therefore, x is, if f of x is odd function, then our value a0 and an will become 0. If a0 and an will become 0, the Fourier series will be the Fourier series f of x equals summation n equals 1 to infinity bn sin nx. It's only the bn term will exist. Now we need to solve for bn. So the bn value formula will be 2 by pi 0 to pi for the range, that is 2 by pi 0 to pi f of x sin nx dx, that is equal to 2 by pi. So f of x will be pi minus x by 2 sin nx dx. So if we observe this, we have two terms, that is 2 and b. Now we need to apply the integration by parts. So what is the formula for the integration by parts? That is integration of uv dx will be equal to, keeping u as it is, integration of v dx minus integration of then differentiation d by dx of u integration of v dx This is the formula for integration by parts. Now we'll solve the value for the Bn by applying the integration by parts. That is Bn equals 2 by pi 0 to pi in f of x sin nx dx equal to n equals 2 by pi f of x, we know that is sin nx dx. We'll consider this is u and this is v. Now with the parts, that is 2 by pi first we need to keep u as it is, that is pi minus x by 2, then integration of sin nx dx minus, then again integration of d by, then again differentiation d by dx of pi minus by 2, and again one integration of v, that is sin nx dx now we need to simplify. Bn equals 2 by pi minus 2. Now what is integration of sin x? Integration of sin x will be minus cos x. We will write it as minus cos, in place of x we have nx, so in the denominator we'll write n, minus in integration d by dx of pi. Pi is constant, so it will become 0, minus x will be minus 1 by 2. Then again the integration of sin nx will be, we know that it is minus cos nx by n, and we need to either this dx is there as it is. Again one more integration we need to apply. The limit is 0 to the next step. Bn equals 2 by pi minus cos nx by n minus of minus 1 by 2. We need to apply the integration again. Minus 1 by 2 is constant, so we will take it outside. Again integration of cos. What is the integration of cos? It is sin nx. Integration of cos will be sin nx, so we'll write it as, again integration of cos will be sin nx by n, already one n we have, so it will become n square. Got it? Now we need to apply the limit. Bn 2 by pi. So here this 2 is there, so we'll take 2 outside. Then remaining will be pi minus x minus cos nx plus sin nx by n square. The limit is 0. So on this, the remaining will be bn equals 1 by pi. Now we need to apply the upper limit minus lower limit. For the whole term, we'll apply the upper limit, and then to that lower limit. Wherever you find x, replace with the limit, that is pi minus, here upper limit is minus cos n pi by n plus sin n pi by n square. This term is upper limit minus lower limit. Lower limit will be pi minus 0 minus cos 0 by n plus sin 0 by n square. So we know sin 0 is 0. Whole term will it will become 0. This sin n pi, sin 2 n pi. So sin 0 is 0. Sin n pi will become 0. Sin 2 n pi will become 0. The whole sine term pi will become 0. The only remaining here pi minus pi, again this also will become 0 only. The remaining part is this. So we'll write it as Bn equals 1 by pi by minus pi by minus pi cos 0 by n. Here we have minus. This pi and this pi will get cancelled. Will be 1 minus into minus plus cos 0 is 1. We know everyone cos 0 is 1. So minus into minus plus 1 by n. So now we got the value for Bn. Bn value is 1 by n. Got it? So now we need to substitute this Bn value to the equation. The equation 1. The equation 1 Fourier series, it states that f of x equals summation n equals 1 to infinity Bn sin nx. So we'll write the equation 1, that is f of x equals summation n equals 1 to infinity Bn sin nx. The Bn value will be summation n equals 1 to Bn value will be n sin nx. So in the place of x, we'll write it as f of x pi minus x by 2. Now we'll consider this as the equation number 2. But in the question they have asked us to deduce the Fourier series to pi by 4 1 minus. So this answer we should get. So how to deduce? In the place of x, we need to replace the x with pi or 0 or pi by 2. We need to check. We got here pi minus x by 2 was summation n equals 1 to infinity 1 by n sin nx. This is an equation number 2. In the place of x, if I substitute with 0, the value will be pi by 2, but I want pi by 4. In the place of x, I'll replace with pi by 2. Replace n equals 1 by n sin n. In place of x, I'll replace with pi by 2. Then here it will be 2 pi. 4 will be 2 pi minus pi will be pi. So now we need to reduce. In the place of n, substitute with 1. So it will be 1 by 1 sin pi by 2 plus 1 by 2 sin 2 will get cancelled, sin pi plus 1 by 3 sin 3 pi by 2 plus 1 by 4 sin 2 pi, and it keeps going. Now pi by 4 equals 1 by 1 sin 90. Sin 90 is 1. Then sin 180 is 0. Sin 2 pi, sin 3 pi, sin pi, everything will become 0. Sin 3 pi. Sin 3 pi value will be minus 1. Will be written as minus 1 by 3. Then next 1 by 5 plus 1 by 5 minus 1 by 7. It keeps going. Therefore, the reduced Fourier series. Hence, good.